One important thing to note now is that if you have a non-normal distribution of raw scores, for example, you have positive or negative skewness, the z-score transformation will not fix that problem. If you map out the position of your raw scores under the bell curve and then map out the position of your z-scores under the curve, you will see that the position of the scores is the same, no matter what system of numbers you are using. A worked example of mapping out scores under the bell curve is linked next to the link for this video. Although z-score distributions have distinct advantages, many people find them cumbersome because they contain negative values and decimals. For this reason, it's common to standardize a distribution by transforming the scores to a new distribution with a predetermined mean and standard deviation that are whole round numbers. The goal is to create a new standardized distribution that has simple values for the mean and standard deviation, but does not change any individual's location within the distribution. A t-distribution has a standardized mean of 50 and standard deviation units of 10. Two examples of other standardized distributions are shown on the slide. It's more practical and meaningful to use an average of 500 as an average SAT score rather than 0. The table on this slide and the graph on the next slide are based on the same information for Joe. On this slide, it shows the sequence of numbers as his raw score of 43 is transformed first to a z-score of -1 and then to a t-score of 40. Figure 5.8 on page 137 in your text provides another demonstration of the concept that standardizing a distribution does not change the individual positions within the distribution. The figure shows Joe's original exam score with a mean of 57 and a standard deviation of 14. In the original distribution, Joe was located at a score of 43. In addition to the original scores, we have included a second scale showing the z-score value for each location in the distribution. In terms of z-scores, Joe is located at a value of z equals -1. Finally, we have added a third scale showing the standardized scores where the mean is 50 and the standard deviation is 10. For the standardized scores, Joe is located at x equals 40. Note that Joe is always in the same place in the distribution. The only thing that changes is the number that is assigned to Joe. For the original scores, Joe is at 43. For the z-scores, Joe is at -1.00. And for the standardized scores, Joe is at 40.